So this is the last video for this section, and I'm going to do an application. There's several applications in the Learn section you'll see, and you should go through those and try to understand them. They're all pretty basic. They're not much different than this example. They're pretty similar. Anyway, so there's things like decibels, there's intensity of earthquakes, and I think one or two others. And there's pH, so I'm going to do the pH one. So the pH of a solution is given by the opposite of the log of the concentration of what's called the hydronium ion. So concentration of hydronium ions. That's H3O plus. So it's H2O, which is water, with a hydrogen nucleus or hydrogen ion added, and that's what gives it its positive charge, is that extra hydrogen ion. Okay, so you're measuring the concentration of that. Solutions with a pH less than 7 are acidic, and those with a pH greater than 7 are basic. The reason for the minus in front of the log is if you don't have it, your answer will be negative, and they just wanted the pHs to be positive. There's no reason to measure things, with negatives. So, for example, the pH of a solution is 7.6. Find the concentration of the hydronium atoms. Write your answer in scientific notation with two significant digits. I'll show you what the significant digits means when we get to that. So solution, pH, I just write out the formula. This is just a good habit. Write out the formula without plugging any numbers in. pH equals the opposite of the log of the concentration of the hydronium atoms. Okay, they told us the pH was 7.6, so I put that in. Now I need to get rid of the log. So first, the negative's in the way, so I just multiply both sides by -1, and I get this. Now, that's a log base 10. Remember, with a log base 10, we don't write the base. So that means I need to compose both sides of the equation with the inverse function of log base 10, which is the exponential function base 10. What that does is it puts a 10 in the base and the left side in the exponent, and on the right side it puts the 10 in the base with the log of the concentration of the hydronium atoms in the exponent. That was a mouthful. So we get 10 to the minus 7.6 equals 10 to the log of the concentration of the hydronium atoms. And then the exponential function base 10 here and the log base 10 cancel, and you just get the concentration of the hydronium atoms on the right side. So we got rid of the logarithm, see? And now, that is not scientific notation. Scientific notation has one digit between 1 and 9, then a decimal point, and then the other digits to the right of the decimal point, times 10 to some integer power. It can be a negative integer, a positive integer, or 0, but it can't be 7.6 or negative 7.6. That is not scientific notation. So I put that in my calculator. It's a really easy step. Don't miss it. Put it in your calculator, and it comes out with this 2.5 times 10 to the minus 8. Now, it had more digits to the right of 5, but it says two significant digits. That means 1, 2. So significant means that you don't have zeros in front of it. Remember, if you multiplied this out, you'd have 0.0000, I think like 7 zeros, and then a 2 and a 5. So the zeros in front are not counted when you're counting, quote, significant digits. So it's just these two. Okay? So that's just commonly used with scientific notation, that terminology. So I got 2.5 times 10 to the minus 8 moles per liter approximately. And that's that.